Resilient Autonomy for Unmanned Systems is a Phase 2 SBIR by Weather Gage Technologies. Weather Gage's mission is to develop and field autonomy software that enables resilient machines to perform when things go sideways. Weather Gage is focused on bridging the technology valley of death, promoting rapid transition of emerging AI-enabled autonomy techniques into next-generation Department of Defense platforms. Weather Gage spans the platform lifecycle, starting with requirements assessment, which is based upon our first principles understanding of autonomy as a form of command and control in which machines are allowed to make the decisions. Using information theoretic techniques developed by the Weather Gage principle, our requirements assessment identifies the optimal use and preferred times for which machines should be allowed to make decisions. Weather Gage engages in focused fundamental research with our partners in academia, taking leading emerging techniques from our academic partners and applying them to mission-specific needs emerging from the Department of Defense. Having proven our new techniques in the laboratory, we then take them to the field in partnership with our industrial partners, primarily the prime contractors. Finally, after advanced prototypes have been proven, we then work with prime contractors to inject the AI-based autonomy technologies into programs of records, providing advanced platforms for the Department of Defense. Weather Gage specializes in 3 specific areas within the autonomous systems space. First, Weather Gage focuses on externally focused autonomy, where Weather Gage artificial intelligence software enables teams of unmanned vehicles and manned-unmanned teams to observe and understand the operating environment, provide shared situational awareness, and devise and execute a course of action. Weather Gage unmanned system autonomy is specifically designed to sustain mission effectiveness in denied environments when unexpected attrition and adversary actions render pre-existing plans unusable. Our second area of focus is intelligent fault management. This is inward-looking AI and autonomy, where we manage unexpected failures to complex mission-critical machines, where failures can place operational success at risk. Weather Gage specializes in advanced distributed artificial intelligence methods that enable complex machines to predict, detect, and manage system faults. The use of these technologies provides improved resilience in complex interconnected systems, including spacecraft hotel systems, ship auxiliary systems, power utilities, and cyber physical systems. The third area of focus is autonomous systems testing, where autonomous systems' ability to interact with the outside world in complex, unpredictable ways presents a unique set of test challenges. Weather Gage specializes in the measurement and assessment of autonomous systems and the development of test and evaluation tools designed specifically to guarantee performance assurance of autonomous systems in complex dynamic environments. Weather Gage expertise spans the test and evaluation lifecycle, including formal methods assurance of algorithms and software-in-a-loop testing, hardware-in-a-loop testing, including live virtual constructive testing. Weather Gage is a fairly new company, founded in 2017 as a one-man consulting company. From small beginnings, we have experienced exponential growth and are currently over 20 staff. Under this SBIR, Weather Gage Technologies developed autonomy software that enables teams of unmanned air systems to function in a resilient manner. By resilient, we mean that the unmanned systems are capable of maintaining mission performance in the presence of unexpected occurrences, which can include attrition, denied environments, including GPS denial and comms denial, and new unanticipated objectives, such as pop-up targets. Some of the key aspects of our autonomy software developed under this SBIR is the on-board planning that is capable of providing effective unmanned air system coordination with varying degrees of complexity, operating in denied environments in which communications are limited and full connectivity between unmanned air systems may not exist for periods of an engagement, guaranteeing that a priori operator-provided rules of engagement are not violated, and supporting coordination between heterogeneous teams of unmanned air systems that may vary in payload, communications transceivers, and mobility characteristics. Prior DARPA studies demonstrated that when compared to current unmanned systems operations, incorporating autonomy into unmanned systems significantly accelerates fleet decision-making, which, in turn, increases fleet survivability and fleet lethality. Under this SBIR, Weather Gage has provided autonomy that we have shown in results can accelerate the decision-making of manned-unmanned teamed assets to improve mission performance. Our autonomy improves fleet performance capabilities by, first, enabling unmanned assets to sustain mission effectiveness in contested, denied environments by autonomously adapting to threats, by reducing operator workload to enable situational awareness exchange and tasking from manned assets, and by enabling unmanned systems to adapt to the unexpected while in emissions-controlled and denied engagements. Weather Gage's autonomy components are reusable software objects that are designed to operate in platforms using the code, FACE, and UCS autonomy frameworks. This enables Weather Gage's autonomy components to easily integrate into emerging autonomous platforms under development by NavAir. The code, FACE, UCS autonomy framework has been successfully demonstrated by Raytheon on the DARPA Code, DARPA Gremlins, and SCO Avatar programs, and is transitioning to PMA 281 for deployment on multiple platforms across the fleet. Weather Gage autonomy components are suitable for use in other autonomy frameworks, such as Skyborg and OMS under use by the U.S. Air Force, UMA, which is used by NAVSEA for unmanned surface vessels, and Moose IVP, which is used for undersea vessels. All Weather Gage autonomy components share the following resilient attributes. They are capable of sustaining mission performance in denied and NCOM environments, capable of adapting to in-mission changes to objectives and rules of engagement produced by authorized operators or pilots, capable of adapting plans, routes, and actions in response to unexpected changes in the environment, including pop-up targets and pop-up threats, capable of reallocating resources and modifying task allocations to modify plans to overcome attrition and or onboard component failures, and capable of satisfying rules of engagement, including DoD 3009 constraints and directives. Under this SBIR, Weather Gage has developed a suite of reusable, portable autonomy components, including fleet communications, which includes a communications chain behavior and an adaptive information exchange protocol that combine to produce an adaptive fleet communication system that facilitates communications between platforms in denied or contested environments. Also developed is multi-static ISR, which is an autonomy behavior that enables teams of mission-controlled vehicles to use the return from standoff radar transmission to search and, upon detection, classify and track targets at an extended range beyond that which is normally available through a single radar transmitter. K-vehicle geolocation is an autonomy behavior that enables vehicles to use TDOA localization to provide position data to disadvantaged or GPS jammed users and or to localize RF-emitting targets. Predictor generates forward-looking situational assessments based on current situational awareness. For any arbitrary time in the future, the predictor generates a map that first defines anticipated location of blue forces and targets, including probability distributions, defines knowledge gaps, such as anticipated blind spots, and blue and red force communications range and reach. The predictor is useful as a portion of an advanced planning system, but is also useful and being used as a tactical decision aid to allow operators to understand what the future is going to look like in terms of future situational awareness for the blue force of autonomous vehicles. The task allocator autonomously assigns unmanned vehicles to current objectives, including emerging objectives produced by top targets, threats, or attrition. Our task allocation approach is particularly unique in that it is fully decentralized and delay tolerant, as it does not require centralized planning mechanism. Distributed data fusion provides shared situational awareness between teammates over unreliable communication. Again, like the task allocation system, it is capable of functioning in a delay tolerant, denied environment in which communications is sparse and a spanning tree is not available to allow all vehicles to communicate together at any one time. Finally, we provide intelligent fault management for the unmanned systems, which enables systems to predict, diagnose, and manage subsystem failure, such as loss of a gimbaled camera or other subsystem within a platform within the suite of autonomous systems. Weather Gage uses a common progression for developing all of our reusable autonomy components, starting with initial early development in an abstract form using the robot operating system. Once we've proven out that the underlying algorithms are functioning correctly and performing the service as required, the system is then ported to the DARPA code system, making it suitable for porting into a code-based platform. Following the initial deployment in the code system, we demonstrate that on a government system using the current SCO avatar build of the code infrastructure. All of these systems are scheduled for a flight test in the spring of 2023, which will be the graduation exercise for our Phase 2 SBIR. Prior to the flight test, we do a thorough robustness assessment where we use Weather Gage's custom autonomy evaluation tools to conduct large excursions of experiments, validating that our autonomous subsystems will function under any and all circumstances, including a variety of red team behaviors and actions. Upon completion of the robustness test and the flight test, a software development kit will be provided to NOC-AD for storage in the Radar repository. Weather Gage anticipates 3 primary transition vectors for the intellectual property developed under this SBIR. First and foremost, Weather Gage will be transitioning our autonomous subsystems to the NOC-AD Radar Autonomy Repository for use in NOC-supported autonomous unmanned programs of records. Second, Weather Gage anticipates supporting our industry partners, particularly the prime contractors, as a subcontractor to help integrate the autonomy capabilities developed under this SBIR onto platforms being developed by prime contractors. Third, we anticipate transitioning those autonomous subsystems that are amenable to other forms of unmanned vehicles, such as unmanned ground, surface, and undersea vehicles, to programs of record outside NAVAIR in the larger DoD industrial complex, including and particularly PMS 406 and unmanned surface vessels and USAF. Thank you for your kind attention. Should you have any questions, please do not hesitate to contact us at Weathergate Technologies, 175 Admiral Cochran Drive, Suite 302 in Annapolis, Maryland, or to reach me, David Scheit, at dscheit@weathergagetech.com, or call me at 410-271-2855. Thank you.